So hello guys, welcome back to my channel. Hope you're doing extremely well. Without wasting any time, let's continue solving our DSA love bubble sheet. So as you all know, we have done find common elements in three sorted arrays up till now. Our next problem is rearrange the array in alternating positive and negative items with O1 extra space. Let's see what does the problem say. The problem says you have been given a sorted array as input and you have to transform this array into something like this. If you see the maximum element present in the sorted array is at the last index, so put 6 in the first, then come to the first one, that is the minimum, then put 1 here. Then again go to the 6. As you have seen, you have encountered 6, move back to the 5. Now come to 2, now come to 4, now come to 3. Okay, so what you are doing, max, min. Then second max, then second min, and so on. Okay. The trick here, the catch here is you have to do it in O1 extra space. That is no extra space. If it was not given, the question would have been very easy. What you have to do, you will have to create another array and keep two pointers, one on the minimum, one on the maximum, and fill up the array accordingly. But this trick has made this question very, very, very thoughtful. I will not say difficult, thoughtful. It's using extensive math. Not extensive, the maths we have learned in class 6, 7, 8. Okay. How? So now we have been given input as 1, 2, 3, 4, 5, 6, and we saw the output was 6, 1, 5, 2, 4, 3. If I mark the indices here, it becomes 0, 1, 2, 3, 4, 5. Okay. Now if you can see in this array, this was coming from the maximum side, this was coming from the minimum side. This was coming from the maximum, this was coming from the minimum, this was coming from the maximum, this was coming from the minimum. So here 6 is coming from maximum, 1 is coming from minimum, 5 is coming from maximum, 2 is coming from minimum, 4 is coming from maximum, 3 is coming from minimum side. And if you can see now, maximum always occurs at even index in the final array, and minimum always occurs at odd index in the final array. This is our fact 1. Okay. Now you would say that must do one thing. We want 6 at the first position. Remove 1, put 6 here. Remember 1, put 1 here. Remember 2, put 2. Then how would you do encounter 2? Okay, because if you put 2 here, 2 is not going to come here. 2 has its actual position as here. So that swapping approach is not good here. You have to think more deeply. What I'm saying is, in maths, we have learned that dividend is equals to quotient into divisor plus remainder. Okay. The idea I'm going to use here is store two values at same index. Just try to remember it, okay? Because in future, if you encounter any such kind of problem where you have to store two values at same index, it might be possible that you are using this approach only. Now here what I do is I say let me make quotient as my final value, that the value that should be present at the index, such as this one. The final value is 6 here. Divisor as the maximum element present in the array plus 1. Okay. And remainder as the odd value. And transform my array. How will I transform? As you know, if I percentile 2 equals to 0, this is occurring in a loop that I is going from 0 to n minus 1. If I percentile 2 equals to 0, that is even index. For even index, what should I do? My final value should be the maximum m, that is capital M. So ARR of m into divisor is my maximum maxi plus 1, that is maximum plus 1, plus my old value is the element present on ARI. Put this element on ARI instead of the previous one. Okay. Else, if I percentile 2 equals to 1, that is for odd index, just replace m with capital M with small m, that is ARRI will become ARR of small m into maxi plus 1 plus ARR of I. Also, after doing this operation here, you will have to increment m plus plus, and here you will have to decrement m minus minus, because as you can see, after putting them in the array, we are also decrementing the capital M and incrementing the small m. Okay. Okay. Now let's dry run this. How will it occur? Okay. So the input array is 1, 2, 3, 4, 5, 6. Okay. For I equals to 0, the maximum index right now is 5. Smallest index is 0 at the moment. For I equals to 0. Okay. Even so, ARR of 0 will be changed to ARR of 5, that is 6, into the max divisor is 7 here. 6 plus 1, that is 7. So 6 into 7 plus ARR of 0, that is 1. That means the index is 0. So 0, 1, 2, 3, 4, 5. That is equals to 6 into 7 plus 1, that is 43. Change it to 43. Okay. Coming to I equals to 1, A of 1 equals to A of, oh, also M equals to 4 now. Okay, I forgot it. It will be equals to A of M, that is 0. So A of M is 0. Now 43 is has replaced 1. But in my initial, when I was explaining, I wanted 1 only here. So what can I do? As explained, that remainder is the old value. Now remainder is old value. How do you get a remainder of a division? That is dividend percentile divisor. Okay. So what I do is A of 0 percentile 7. Now into 7 plus A of 1, which is equals to A of 0 is now 43, percentile 7 will be 1, into 7 plus A of 1 is 2, that is equals to 9. Change it to 9, increment M and move further. I equals to 2. For I equals to 2, it will change to A of capital M, that is 4, percentile 7 into 7 plus A of uh, 2 only, which is equals to A of 4 now is 5, percentile 7, that will remain 5, into 7 plus A of 2 is 3, so it will change to 5 into 7, 35 plus 38. Change it to 38. This was 9 here. Okay. Moving to I equals to 3. For I equals to 3, A of, oh, also decremented, A of now kept small m, that is 1, percentile 7 star 7 plus A of 3, which is A of 1 now is 9. 9 percentile 7 is 2, into 7 plus A of 3 currently is 4, that will be equals to 2 into 7, 14 plus 4, that will be 18. Change it to 18. Okay. To I equals to 4. So A of 4 will be equals to A of, the index is even, so moving to capital M, that is equals to, what do we say it? Sorry, what do we say it? We say it A of 3 into 7 plus a of 4. Also here it will be mod of 7 also. So a of 3 is 18. 18 mod 7 is, what do we say, 4. 4 into 7 is 28, plus a of 4 is currently 5. So 28 plus 5 gives us 33. Change this value also. Okay. For I equals to 5, a of 5, this is 2 here. A of 5 now is a of m, that is equals to sorry, I've not incremented it at the right place. It will be 2. It would be a of 5 will be equals to a of 2 mod 7 into 7 plus a of 5, which is equals to a of 2 now is 30. 30 mod 7 is 2 into 7 plus a of 5 is 6, which is equals to 14 into 6, that is equals to 20. Okay. Change it to okay. Now what should we do now? So up till now this was our transformation 1. Okay. Time complexity for this transformation is O of n and space complexity is O of 1. Okay. We are in the limits right now. We have not exceeded our limits. Now come to the transformation 2. Transformation 2 is really simple. It's time for transformation 2. It is actually very simple. Transformation 1 was the one where we have to apply our mind. For transformation 2, we know that we appointed quotient as new value, and to obtain the quotient we can just do ARRI by divisor, and here we are doing integer division. So let's check if it is working for the given test case. 43 divided by 7 gives us 6, correct. 9 divided by 7 gives us 1, correct. 38 divided by 7 gives us 5, correct. 18 divided by 7 gives us 2, correct. 33 divided by 7 gives us 5. 33 divided by 4, yeah, 4. And 24 divided by 7 gives us 3. So as you can see, we have obtained our answer. These were the only steps. Let's come down to the code. It will be more clear how we have to proceed in the coding area. So now let me declare some variables right away. So my long divisor is ARR of n minus 1 plus 1. My minimum index is small m is 0, and my maximum element index is n minus 1. Now for int I equals to 0, I less than n, I plus plus, ARRI will become ARRI percentile divisor into divisor. ARR of, sorry, this will be equals to, sorry for the mistake, it will come when I is, if I percentile 2 equals to equal to, for the even case it will come, right, ARR of capital M, and decrement that M after the operations division plus remainder, that is ARR of I, that is the old value only. Else for even values, ARR of I equals to ARR of small m plus plus percentile divisor into divisor plus ARR of I. Okay. Then transformation 2, that is for int I equals to 0, I less than n, I plus plus, ARR of I becomes ARR of I by divisor. Okay. This is the only thing we have to do. Let's try to compile and run it. Hope it works. Working for the compile and run test case. Let's try to submit also. Submit it correctly. Thank you for watching. Hope you liked the video. Please don't forget to subscribe it. And also, if you have any recommendation or anything you have not understood from this video, do leave a comment. I will surely get back to you within 24 hours. Okay, have a nice day. Goodbye.